Welcome to everybody. Good morning, good afternoon, good evening from all the audience. It's really a pleasure to have you today for this new session of the Index Conference by the Sfen, the French Nuclear Society. So it will be a two-step web conference today. First, a panel with some safety authorities, and then two keynotes from the European Commission and from the IEA. So we'll start with the panel of safety authority, and it's a pleasure and an honor to welcome today Christophe Quintin, Chief Inspector at the IRSN, the French nuclear regulator, John McKirgan, who is from NRC. He is a Deputy Director of the Division of Engineering at the Office for Nuclear Regulatory Research. So be warmly welcome, John. And we have the pleasure to welcome Igor, who is Director for the Safety Assessment at the IRSN, the French technical support for the IRSN. So probably you are familiar now with the Index Conference. It's a conference organized by the Sfen. It's an international conference about the digital transformation in nuclear. And it's the second edition of this conference. And this new edition is remote through the web. So be welcome with us today. You can ask questions. And you can ask that through the tab, through the icon, which is called Slido, at the top of your screen. And you can ask questions there and vote for questions that have already been put on the screen. And the moderator will first go through the questions with the most votes. If you don't have the tab Slido, I understand that you can go through the chat and there you will find a link to the Slido. So this is for the logistics. Our panel today with the safety authorities deals with the digital innovation, the opportunity and the constraints they bring for nuclear safety. As regards nuclear safety, digital innovation can concern two fields. The digital INC, control and command. And a lot has been said already for decades on this topic for nuclear, for aeronautics, for the metros, etc. And we are not going to dwell on that very topic today. We will rather address the new ways of working which are developing through digital technologies. Those technologies can be the more plant parameter monitoring, remote inspection, data lakes, artificial intelligence, digital twins, digitalized engineering processes, the PLMs, and the extended enterprise. And the purpose of this panel is to analyze how the work is changing, how the relationship between the operators and the regulators are transformed, and eventually whether the nuclear safety is likely to improve or to be challenged through the digital transformation. And there are many questions we can ask ourselves about it as far as regulators are concerned. The regulators, their first task is to appreciate how the operators fulfill their nuclear responsibility. Does digital improve or impair this task? How does it change? Does the change of the tools, like digital twins, like artificial intelligence, does this change modify the safety demonstration and the way to review the safety demonstration? Another question is, if the regulators have all the data through shared system, do they feel obliged to process all the data, or can they still sample their reviews? And if everybody works on the same data with the same systems, can we impair the independence of the review? everybody focusing on the same thing. How think out of the box. There is also a question of competence. What change in the competences within the regulators and the operators through this transformation? And finally, what is changing in the regulatory work, in their responsibilities, in their relationship with the industry? Those are the types of questions we intend to dig today. And I will ask the first very simple question to the panelists. Now, what strikes you most as regulators in this transformation? What is the main change? And what do you feel about it? First, I will let the floor to Christophe. Quintin? The floor is yours, Christophe.
Thank you. Thank you for inviting me for this meeting. What strikes me more is, first of all, the fact that we have no choice. Digitalization is something that is mandatory today, but we have to think about it as a new way to do the same job as before very often. And except for something like artificial intelligence, IA, very often it's just another way to do the work. And very often, one of my concern is that the fact that when designing new systems, inspectability is not taken into account. And you have asked a question about data and sampling, for instance, in France and very often in other regulatory bodies. We do not want to have exhaustive data, but we want to make samples. And if the software is not made to make samples, we may have a problem. And that is a major concern for me. And another concern for me is user interface design and user acceptance. That is something that is very often seen when we go in the field to inspect people. Very often people are reluctant to change the way they work. And sometimes the user interface is not very helpful for them. So these few topics are, for me, what strikes me more. Your micro is off.
Excuse me. I should be able to manage that, but it's my job. But so John, on the other side of the Atlantic, what is your view on that?
Yes, thank you. Thank you first for inviting me. I'm very excited to be here this morning. So thank you, and I also appreciate very much this topic. I think it's marvelous that you're pulling together this because it's an important topic, as Christophe just said. As I thought about this problem, there were four points that I'd like to offer this morning, and I'll be brief. But certainly, the rate and scope of change in the transformation is an item that we're focusing on, and also understanding the problem space. It is a dynamic environment, and the problem space that we're facing is constantly evolving. Certainly, we need to focus on properly validated and verified models and data that have an impact on safety, and then also looking at some early indications from some of our virtual inspection activities. And so, if I could, I won't take long, but I'll just talk for a moment on those 4 points. There are two notable aspects on this first point about the rate and scope of change in digital transformation, including the technologies and applications. The rate of change is significantly faster and broader than we've seen historically in the nuclear industry. And these changes are mirroring the industry at large. But I would offer that, at least to our experience, the nuclear industry is one that's more acclimated toward a more deliberative, incremental change. And as I see digitalization globally and across all industry sectors, it's moving very quickly. And I think it's important for us in the nuclear industry to be very deliberate and focused on safety as we move forward. So another aspect of digital transformation is the expanding set of unknowns, the problem set. As these digital technologies come forward, they introduce new variables, new unknowns, if you will, that we need to understand. And this introduces new uncertainty. An understanding of the totality of the platform, the landscape that is before us, and prioritizing in that very dynamic environment which uncertainties we need to focus on as a regulatory body. So as the NRC prepares for this transformation, we've maintained a risk-informed approach. We are trying to continuously focus on the most safety significant elements. We've tried to be proactive in this very dynamic environment to understand this evolving problem space. And of course, like all of you, engaging with our industry, our national laboratory system here in the US and international partners. And so I think it's marvelous to pull together a conference like this so we can identify the technical and regulatory challenges and gaps and gather insights. So with this large influx of new data, new modeling techniques, it's important for us to be able to focus on the most safety significant issues. There is such a large volume of data and information being presented through digitalization, and not all of it is critical to the regulatory perspective. There are many business aspects that are valuable for efficiency and effectiveness of the business operations. But at least as the regulator, we want to focus on those that have the most safety significance. And whether those models are physics-based or data-based, they need to be validated and verified and grounded in reality. And again, my last point that I'll try to wrap up is we do have some early indications from some of our virtual inspections that were done during the pandemic that has kind of forced us to look at new business operations. And to that end, there were some that I think we would all conclude could be done virtually, but it's certainly apparent to us in the US that there are some inspections that really need to be done in person and have people in the field. And so I'm sorry I went a bit long, but I'll stop there and turn it back to you, Bertrand.
Thanks a lot, John. You have been perfect and not long at all. Igor, coming back from on this side of the Atlantic from a TSO perspective, what strikes you?
Hello, everybody. Thank you, Bertrand. Obviously, new technology is very promising in the best use of the means on our technical capacity. And as said Christophe, we have no choice. But as a technical support organization, it's with a view of assessment of safety that I'm going to answer. And for me, there is two things very important. First, the spectrum of technique and subject associated with digital innovation are very large. Natural language processing, machine learning, deep learning, twins, and so on. And in the nuclear safety, there is a lot of actors, operators, subcontractors, safety authorities, TSO, stakeholders. And all these actors can be affected in different ways by the digital development in the field of nuclear safety. And it must be a global transformation. As said John, all the actors must continue to understand all the aspects of nuclear safety. It's very important for me. And it raises a question about the skill of all the actors. How to define on how to organize the change in skill. It's a very important question. And the first question is what tools are being used and developed in nuclear field? It's very difficult to say today because there is a lot of idea, a lot of project, but in which project TSO, Safety Authority, must increase her skill? I don't know very well. The second point is how to comply with the regulatory requirement, the tool of tomorrow. According to the regulatory text in France, the safety demonstration must be based on appropriate, explained, and validated method, integrated hypotheses and rules adapted to the uncertainties and limit of knowledge. It's a rule in France. Another safety guide in France say taking into account consideration proven industrial practice make it possible to benefit from feedback and feasibility and so on. So there is a very important state of art in a nuclear safety framework. It takes very long time to develop this regulatory requirements. And for me, it's a very important challenge with the current digital because they are numerous and they change very rapidly. So how to adapt a very long state of art with this type of technology? Mm-hmm. For me, this is 2 points, skill on how to change state of art are very important.
Thanks a lot to you, and we see some converging questions or statements about the speed of the transformation in an industry which likes to be based on the state of the art and with usually quite long changes, and also the scope of all the data and the question it raises about focusing on the very safety questions and not losing track of those. And this leads me to an additional question. Through the digitalization, do we get closer to the reality thanks to more data and better simulation? Or do we risk losing contact with the field, with the physics, with the people? And when the digitalization improves the efficiency of the routine tasks, how do we use the time we have saved to do more of the same or to go more in the field? So can you elaborate, each of you, about this question of the being close to the reality? Christophe?
Okay, it's a very interesting question. I think that there is an exception for plant parameter monitoring, where in fact digitalization can help to be closer to the field with more parameters. That's permitted by digitalization. But except that, generally, with digitalization, there is a major risk to be further from the field and from the reality. There is a major risk to live in a virtual world where you, with the confidence in the data you have collected, and if you do not have control on human tasks at the beginning, you have a virtual world. And what we often say is that if you have a garbage in, you have in fact garbage out. And the major issue is not to have garbage in. And it's very easy to tick a box in the field and not to do the job, for instance. And after that, in the process, you will see that the job has been done. And if you haven't someone to control that the job have been done effectively, you will live in a virtual world. So this is a major issue due to digitalization. And that's why, for me, when you will gain time, and this time you have gained must be used to go in the field, and essentially in France, where you know that management does not go very often in the field. It's a French culture. We need to have managers in the field, and the time they will gain with digitalization can be used to go in the field.
Thanks a lot. Very clear, Christophe. And John, in North America, is the perspective the same?
No, thank you. I think we do share many of those perspectives. But as I thought through this, I think there are just maybe 3 points I'll offer here. So certainly the better data and simulations can allow operators greater insights. I think that's well understood. The operators and regulators have to maintain this perspective on the physical realities that are present, and the data and models need to be properly validated and verified. And so let me dwell on those 3 points just briefly. So any model, any abstraction has this risk of getting you away from the reality, and getting direct feedback from the physical world is certainly very important. Technologies like digital twins, which we mentioned and are emerging, when implemented, they can inherently rely on inputs and updates from the physical world, and at least in our terminology, we call that maintaining state concurrence. I'll offer very briefly, this is a very dynamic environment, and even things like terminology, the taxonomy of some of these digitalizations are evolving. And so it also becomes important that we explain ourselves when we use terms and phrases that are new, at least to our industry. And so developing common terminologies and standards is certainly an area that we'll have to continue to explore. But so state concurrence is important, and that feedback with the physical world is a key element. So digitalization has the capability to provide operators and regulators with additional insights that they wouldn't have otherwise have had. And it's important to maintain a perspective on what that data and models are representing. There's that expression, all models are wrong, but some models are useful. And now that has been pervasive through the nuclear industry since its inception. I think what we are seeing now in digitalization is an exponential growth in the use of these models, and the level of abstraction is becoming extreme. And so maintaining an awareness and focus on that, again, I'll go back to state concurrence, that ground truth is going to continue to be key. So the transformation to digitalization, coupled with the development of advanced reactors, presents a unique challenge. And I don't think I've spoken yet about the operating fleet is digitalizing, but the advanced reactor fleet, the next generation, will probably by design incorporate more sensors, and it will represent an even more advanced and a faster paced digitalization than retrofitting the operating fleet. And that's something that we'll have to look at even more so than in the operating fleet. And again, looking at the uncertainties associated with new reactor physics in new reactor designs, coupled with digitalization, will represent a multiplicative challenge for us as safety regulators. And so I'll pause there. But thank you.
Thanks a lot, John. And Igor, on your side, from in IRSN, getting closer to reality in the field in physics, or
so digitalization will increase our capacity to have data and to use this data. And it's very important. And I'm sure, for example, like Christophe and John, it's very important in the monitoring of nuclear installation. I think future installation will have more monitoring, and it's a very important point. And another point, I think more data would be an important point in the use of feedback. How to use the feedback. There is a lot of opportunity in digitalization to have a better analysis of the feedback and to find very common point in the feedback. But as your question underline, losing contact with the field is a real risk. For example, for IRSN, the compliance of nuclear facilities with the safety requirement is a very important point. And digital twin will not be able to quickly translate all the event in the installation. If you have an error, if there is an incident, and so on, there is a gap between the digital twin and the reality. And for example, for safety, if you use only the twin, it's not a good aspect. So it's very, for me, we will carefully about to take the twin as a reference. Another point for me, very important for the field, feedback shows that the detection and management of unforeseen events is very important. For example, in France, we have currently a question about unanticipated corrosion. Mm-hmm. It's important to have the capacity, that the operator has the capacity to detect and manage this type of events. And you don't find this event in digital twin because it's all you think it's physically correct. So for me, it's very important to keep the field and to have a view of the safety in the field.
Thank you very much, Igor. I think you have drawn a very broad and clear picture, all of you three, about the challenges and the opportunities for the regulators and for the nuclear safety, about digitalization. And you said very clearly also that the pace of the transformation is very fast, and it concerns all the actors and all the topics, and in various ways. So it's a global system which is transforming. And so this system, this global transformation, how do we manage it globally in order to mitigate the risks and maximize the benefits? What link with the complexification or simplification of our work? So how do we manage that so that eventually the nuclear safety will be improved thanks to digitalization? Christophe, you wish to start?
I think that digitalization is very useful when it can reduce interfaces between different bodies or different enterprises. And what is important is to first think about what we want to do. And just to answer your last question, it's quite stupid to digitalize a process that is not optimized. And so it's a good thing to re-engineer your process before digitalizing it, so you can have something that is better for safety and for business also. And very often, people do not think about new risks introduced by the digitalization, and that is something you have to do before digitalizing. I will take just a small example. A few months ago, I went to an inspection on a nuclear power plant in France, and I just wanted to check something that EDF have promised us after a safety event. They have, on this side, they have decided to change a procedure. And this was done. The paper procedure was changed. But in fact, when we inspect this, we have discovered that people do not have the right procedure because they do not use the paper procedure. They use a specific software application that they have been designed for them. But this software application, when they designed it, they do not think about the fact that they have to be consistent with the paper one. And so the risk analysis was not made. This is a very small example, but that's something you have to take into account. When you design a digitalized process, you have to think about what are the new risks that are introduced in the process relative to safety. And I haven't seen very often this kind of reflection at the beginning of digitalization process. And in fact, so if you re-engineer your processes, you can gain in complexity, and in fact, at the end, you will have something that is leaner. So that will be interesting.
Thanks a lot. Thanks a lot, Christophe. So, in the US, what is the view of NRC about the way to manage that transformation?
Yes, thank you. Yeah, this is a critically important topic of how to mitigate the risks that are present. And there are 3 points I wanted to touch on briefly. Certainly understanding the problem space, validation and verification, which I think you might detect as a theme in my commentary, and then also applying lessons learned from other industries. And let me start with that last one first for a moment, because as I mentioned before, and I think we all recognize, digitalization isn't unique to the nuclear industry. In the nuclear industry, we have an extremely high dollar value asset with extreme importance to public health and safety. But there are other industries that are also incorporating these things where the risk profile is very different, and the assets are more expendable and can be tested and explored a little bit more readily. We might think about the automotive industry or just a variety of other industries that are applying digital twins. They're also applying artificial intelligence and machine learning, and I think it's valuable for us to study their lessons learned. In some instances, they are a little ahead of the nuclear industry in deploying these technologies, and so I think it's extremely valuable for us to learn those lessons from other industries. The other item I'll offer is, at least in the US, I think the way we see some of these things deploying is to pilot them on lesser safety significant systems first. Digital twins for an individual pump, for example, or applying AI/ML to prioritize inspection sequences. And so taking these smaller bites at the digitalization apple, I think is one way to help mitigate the risks. Of course, as industry deploys these, the regulator has to be in step with those, and we need to maintain our own competence and qualifications on our ability to inspect AI/ML technologies and techniques. Within the NRC, we do have some programs where we're trying to look at machine learning for prioritizing inspections or the use of drones or virtual reality to analyze radiological surveys and decommissioning. And so looking at these small bites is a way to incrementally approach the more global problem. And so I'll stop there, but I think those are my key message there is applying lessons learned from other industries and starting with the lesser safety significant items.
Mm-hmm. Very clear. Thanks, John. Igor, What would be your input on this question?
First, for me, digitalization is an opportunity. It's clear. But there is, first of all, we have to don't forget that the safety is global. It's not only one study. It's study, conception, manufacture, operating, and so on. And we have to manage the risk to keep this point of view. If you reduce margin, or if you increase uncertainties, it could be a difficulty for the safety globally. Don't forget human aspect. So keep the globality of the safety. And digital introduce new risk and new uncertainties, and you have to address this new challenge. And I agree with you, Bertrand. It's a global transformation. And I would like to underline a very interesting work by the NRC. NRC produced an artificial intelligence strategic plan, and it's a very, very good work. And this work addresses a lot of difficulty and challenge. So read this text is very important. And one of the points of this strategic plan is to make benchmark and make pilot, industrial produce virtual test, and include all the actors in this test to show where is a good question, where is the trouble. And I think it's a very good idea to manage risk. It's to benchmark and to make artificial pilot, artificial test to start to think, because the main difficulty is when an operator put in the safety demonstration a new technology, he wants the authorization, he wants to start 1 year, 2 years after, and it's very difficult. It's a new technology and it's very innovation. So this artificial intelligence strategic plan is a very, very good paper. So if I don't know if you see the document.
Not yet. You're sharing your screen, are you?
It's correct. You see the screen?
Not yet. There is a delay in this case.
It's a very not really. I can't. It's a very good document.
Okay. Thanks a lot. We had, I think, a number of wonderful questions and observations and thinkings, which show, by the way, that it is not in 1 hour that we are going to solve the issues and to address completely this topic. It really it would be worth full day or a full conference on that and working groups to share, which can be an idea for the future, because there is really room for thinking, sharing, and progressing in the questioning and in the solutions. So we have some questions from the audience now. A difficult one, I guess, about artificial intelligence. Are the safety authorities in capacity to give specification for an explainable, a trusted artificial intelligence, which could be used for safety demonstration? Artificial intelligence and safety demonstration. Who wants to become a PhD at the end of the conference?
Bertrand, maybe I could start. I appreciate this question very much, and Igor, I have to thank you for pointing out the NRC strategic plan. And actually, I would point back to that document because I think this raises a number of very key issues that we need to discuss. And this phrase of trusted and explainable, I think, is one. It actually is a term used in the AI field, and it has a very specific meaning. And so I would recommend folks look at the NRC's strategic plan. The other element I'll mention here, of course, is that AI and ML is not a nuclear specific evolution. It is global. It is permeating, I think, all industries. And one of the other items that I'll mention, a risk, is the way AI and ML is deployed has an ability to insert itself into our supply chain, if you will, in a way that's not immediately obvious. It wouldn't be, there wouldn't be an announcement or a notice on a particular part or piece of software that AI or ML was used in its manufacture or is used in its development or specifications. And so I think AI ML has an ability, because it is becoming so pervasive throughout so many industries, it is something that requires a great deal of consideration. And of course, its specific application, as I mentioned, using machine learning to prioritize inspections is something that's fairly discrete and understandable, although it does require a great deal of knowledge in the background. There are other implementations of AI ML that won't be so obvious, and so I'd like to offer that. But again, just the final plug on the strategic plan. I think that's it's a valuable document.
Thanks, Christophe. Igor.
I will let Igor speak, but I would like to say that in France we like determinism for safety case, and this is incompatible with AA. So I don't think we will see very soon something written by the French regulatory body about using AI for safety cases, but it may be useful for other purposes. We use an AI system for analyzing our letters when written after inspection, but we do not use it for building our inspection system.
Thanks, Igor. On the technical side of the regulation, I know you like this question.
I know that.
Artificial intelligence and safety demonstration.
Sure, I like this question. It's a very good question. I think there is two aspects. First, in what the autonomy level of the application. It's an application to help human to find the worst configuration, to determine the optimal parameters and so on. It's to help human. And this kind of application, why not? Because you can't control the result and you can't assess the study. There is another level, is fully autonomous. You can't control the algorithm, the process. You have a too complex situation to control. And for me, this kind of application is very, very difficult. And I'm sure it's acceptable because you can't control this parameter. I think one is very important as one question you say, you have the ability to control and to check the application. So if you have a fully autonomous, it could be very difficult to control so I'm not sure.
Okay. Thanks.
I answer a question. The strategic plan of NS is a public document.
Yeah, I was going to ask this question to the NRC, but the French side knows also that the document is public. So I guess it would be widely consulted and loaded by the audience. A question about the paperwork. We like very much the paper in nuclear safety, and so somebody is reminding us that for a steam generator, in France, the paperwork is as large as 20,000 pages to justify the steam generator. And so with the digital transformation, are we going to make progress in this field and to save the forests and be more streamlined or more efficient in the paper we produce? What is your view? The question was about France, but it's not only about France, but French.
For me, it's not a difficult question. I think this is an easy way to make progress with digitalization, and so we can save trees, as you say, and I think we can also have better processes or inline processes where we can validate some acts in softwares or in the. But we have discussions in IRSN about this, and all people do not agree with me. As I'm not the big boss, we still have discussions. But for instance, with EDF as what they call ESPN digital,
yes.
That is a kind of you have talking about it.
Yes, and there will be a presentation next week on the ESPN digital in the next session of the index. So it's an opportunity to advertise.
Or give authorization in this software, but this is not done today. And we don't need to have papers because this is easy to have only documents stored on servers.
Yeah. I guess France is certainly the champion for paperwork, but maybe US has some too, Joe?
We do. Thank you. And this is a good question. And I would like to pivot the question a little bit, if the questioner will permit me, because I want to think about it certainly in terms of paper. And I think with COVID and digitalization, we certainly produce less hard copy documents, physical paper. I think we've seen a great expanded use of looking at documents online, and so I'll separate out the saving the trees part. But I'd like to also bring this back to the digitalization discussion with the expansion with the use of digital twins and advanced sensors and data lakes, for example, which I think is another topic. There is the availability of a much larger volume of information. And so maybe rather than pages, I might think about volume of information. And I think we all have shared the comment of focusing on the most significant information. And I think that's where I would hope that digitalization will enable us to continue to focus on the safety significant data and maybe revisit some of the reporting requirements and certainly the paper requirements. I do recall, I think in the US, we had one requirement that required a fax number. And so you can imagine that those kinds of requirements are becoming somewhat outdated. But I think the caution we all need to understand is with digitalization, there will be a much larger volume of information, not all of which it would probably be necessary for the regulator to review. But sorting out which is regulatorily significant and which is not, is going to be a continued challenge.
Yeah, and it's not a new challenge. Probably it's the same challenge with a lot of data, and so one of the skills we probably need is all the skills linked to digitalization, but the other skill we very much need, the skill is nuclear safety, to be able to distinguish what are the most significant issues in all the issues and all the data in all the questions. And this is a permanent skill we need, but always probably very important. Igor.
Yes, there is a progress about the paper and document in a digital point of view. I think it's necessary because there is new work condition, virtual office and so on. Need to develop no paper, no, and there is we have some very amazing development now because we develop digital application to read this document now. There is a new application to explore and to find the good information in this paper. So obviously, well, we keep this type of documentation. I'm agree with that, but there is a very important risk. I give you an example. This year, we assess the safety of the new installation. And at the end of the work of IRSN, we find we working on a configuration is not the real one, is not the configuration of the workshop. Because the digital twin change between the operator send his document to the safety authorities and the end of the manufacturing of the workshop. There is a very big risk on check the data. What is the right data? Paper have a big advantage. It's a piece of paper and it's easy to check the data. When you have a digital application, change something in the digital application is very, very easy. How to manage this modification? What is the reference of the safety? A procedure or safety report is a reference of the safety. It's clear. It's not a paper, is it a digital twin? Is it a reference or not? It's very important question, and there is a lot of risk with this type of data.
Yeah, and which links, maybe, Christophe, you wanted to add something?
I just wanted to add another risk that is about falsification. We make a specific inspection today with inspection on suppliers, focused on falsification. And one risk with digitalization is the step where you pass from the real world with the paper to the digitalized process. Yeah. Because all the process is not digitalized. So you are in the factory. You have some figures, and you put them in the system. And this may be risky because there isn't enough controls. You may put a wrong figure, and you may have falsification problems after that. And you have no way after it is in the computer, you have no way to detect this.
That's why it's a way for the future to privilege or to develop the sensors that are directly connected to the system in order not to have to recopy the figures. And your point is very close to come close also to cybersecurity, of course, and there is a question: what are the efforts done to guarantee safety facing the risk of concerning cybersecurity? All the data are in the air, are on the system software somewhere. Is it something which is tackled by the safety authorities or left to the other authorities?
We are conducting reflections about traceability. That's what I said. On the other aspects of cybersecurity, we do not work. We are not in charge of cybersecurity, and so we do not deal with the other aspects except traceability. That is enough for us.
Yeah, and is it the same for NRC?
So in the NRC, we do have regulatory requirements on cybersecurity, and we do have active programs to assess the industry's implementation of cybersecurity, and we have research programs that are very active and becoming more active in light of the question posed here, and certainly other advanced technologies like wireless technologies are also introducing other cybersecurity concerns. So we have a very active program, but I won't belabor it. I'll point back to the NRC website on cybersecurity.
Thanks. There is, of course, there are questions about human resources. We dealt with the skills needed, but also the amount of resource. There is also always a battle for resource in order to be able to review all the safety cases, the authorizations, and do all the work. So do you expect as safety authorities gains, productivity gains in your work through the digitalization? What is your experience now?
Could I again, if I may, I want to speak to two different aspects of that question. It's a wonderful question. So just in terms of human resources in digitalization, it is again, it's a global phenomena. We are competing to obtain experts in artificial intelligence and machine learning and data processing, and it's been a challenge, I think, for everyone. Because, again, globally across all industries, people are looking to expand in this area. And so we at the NRC and even at the nuclear industry, we're competing with the likes of Google or other very large companies for some of these very coveted, skilled individuals. And so that's a key aspect of that. And I think that's the one that's challenging us the most at the moment.
I may answer with two examples. When I inspect EDF, I often use a software that is called Chameleon. That is used, and for me it's very useful, and I gain a lot of time with this tool, and I use it extensively. When I go to inspect a CEA, I lose a lot of time with digitalization because I spend a lot of time in front of blue screens. So the answer is not very easy. Sometimes we gain time with the digitalization, sometimes we lose a lot of time, and I think for IRSN it will be more complicated, in fact. And
so it will be more complicated even for IRSN. What is your view, Igor?
The answer is very clear, yes. Because we make a specific strategic plan about change our tools and introduce new technology. For me, for example, we have a new application about feedback, how to explore the feedback, how to have more rapid and analyze about this feedback with natural language analysis and so on. There is we have new application about expert application. To answer a very simple question, what is the worst configuration for the safety? This type of question, you can't have digital application, intelligence artificial algorithm to develop this type of application. So yes, there is progress and increase in your capacities to assess safety with this type of technology. As said before, we have the need to keep the control.
Yeah.
This application help to the expert work, but you have to keep the control of the application.
Maybe this could be the final word, keep the control. That's good for a final word of a safety authority panel. So well done, Igor. Thanks a lot. There are many other questions from the audience, from myself, from everybody. Of course, in 1 hour, we have not dealt with all the questions, all the topics, not solved everything. And so I think it's a call to renew this type of discussion and panel and have working groups on that. So thanks a lot to the panelists, to the audience. It was most interesting. Some logistics. This panel can be replayed on the Sfen YouTube channel. It will be soon in the air. Of course, the CVs of our panelists are on the Index website. And for the next session about the keynotes, everybody is invited to attend, of course. Technically, we have to disconnect and to reconnect with the specific link sent by the Sfen. It's purely technical. We need to. So thanks a lot. See you soon. And on the keynotes in 15 minutes now.
Thank you.
Bye-bye.
Thank you. Bye-bye.
Bye-bye.